Welcome everyone, and thanks for having me, obviously. So my name is Mauro Servienti, and as you may guess by my accent, quite a funny one, I'm Italian. So I'm sorry about that. So up to you to decide if you want to be sorry because of my accent or because of my Italian. But anyway, so I'm a remote worker. In the company I work for, we are all remote workers. We're spread across 17 time zones, and we all work from home. But unfortunately, the flat I live in with my family is too small to work from, well, the small kitchen table. So I rented an office that is a few meters away from where we live. And I usually bike ride to the office. And my favorite snacks are bananas. So can you imagine what happens when you put your banana into the backpack and go for a bike ride? That usually doesn't end well. So after failing very badly for my poor backpack a couple of times, I decided to try to fix the thing. So I headed to my favorite e-commerce website and looked for this. So that's a banana protector. It's a real thing. I was surprised, by the way. And by the way, it has 26 customer reviews. And there were instructions as well inside the package. So, well, anyway. So I had it there, selected the one. There's thousands of different products to protect your bananas. But I selected one, the best one, according to reviews, and I put that into the shopping cart. And at that point, the architect, constantly working in the background in my mind, said, hold on. That looks like a nice aggregate, doesn't it? So the shopping cart is a business concept. It sounds like it's isolated. It has a bunch of data. I'm summarizing data that you can find generally in a shopping cart. So we have, I don't know, the item ID, probably that is not available to users, visible to users, but the price, quantity, inventory, name, description, the image of the product, whatever. A few information connected to the product you're trying to buy, and it has behaviors. So it sounds like perfectly fits the definition of an aggregate, data and behavior. And in fact, we can delete the thing, save for later, whatever it means, and change the quantity. So we can act on the shopping cart item and change its state. Unfortunately, sometimes the business comes to us and say, well, I'd like to have a new feature in your nice-looking shopping cart. One of which could be, you know what? Law doesn't allow us to change the price once the thing is in the shopping cart. So the price cannot transparently change under your feet while the thing is in the shopping cart. So straightforward, isn't it? Price is owned by something that we can call sales. We copy over. So we basically say, when you put the item into the shopping cart, we're copying the price of the item to the shopping cart. We're basically denormalizing data over to the shopping cart. So we're saying, now if the price changes, it's not a problem at all, because we copied the price at the time the thing was put into the shopping cart. And then the business come along again and say, well, I'd also like to show to the users for a psychological effect so they may buy faster, how many items are left in stock. And by the way, they always lie. And still not a big deal anyway. So maybe that information is owned by warehouse, and we can copy it. So whenever we add the item to the shopping cart, we say, well, let's copy the price, and let's copy the current inventory item. However, availability changes over time. So now we're left with a situation in which every single time warehouse detects a change in the availability of an item, should go to the shopping cart and say, hey, do you have this item in one of the shopping carts you are currently handling? If the answer is yes, please update the availability to the new availability, whatever it is. Because users are constantly going to the shopping cart page, and we want to show the availability in some way. And that, obviously, goes on and goes on and goes on. So it's a constant flow of interaction between warehouse and the shopping cart. And then the business comes back again and says, well, you know what? Still, due to regulations, whenever something changes its price, we're not anymore allowed to leave the thing into the shopping cart. If we want the price to change in the shopping cart, we need to do two things. One is update the price and show the previous price and the current price to the users, and then remove the thing from the shopping cart, and possibly, because we want them to know that they were trying to buy the thing, move it to another section on the same page. Let's call it the saved for later section. So in this case, it's not that straightforward anymore, because originally the shopping cart contained one single information, one single price. So now we're required to change the shopping cart structure to be current price, last price, whatever we want to call it, in lack of a better word. And then every single time sales changes the price of something, they need to go to every single shopping cart and say, hey, do you have this item into any of the shopping carts? If yes, can you please update the price to this new price, swapping prices, so the current one go to the last one and change the current one, and by the way, move it to save for later. So basically, smell it. It smells, doesn't it? So there's something that is happening here, because even this kind of interaction goes on and goes on and goes on. So the big picture, it's becoming messy. And if we start introducing more actors into our system, it becomes even messier, because we have more interactions coming from different places into the shopping cart that starts looking like a shared resource or a contention problem. So, and obviously if we add shipping, for example, in this case, it's again very similar to warehouse or part of sales. So whenever the shipping availability or the estimated delivery time changes, shipping needs to go to the shopping cart and say, hey, can you please do something for me? What's the basic problem we've just introduced, or we realized we have in a system like this? That we lost autonomy. So basically, it's a monolith. We need to be honest with ourselves. So basically, we have lost autonomy because now the shopping cart is basically controlled by something that has nothing to do with the shopping cart itself. So changes in a part of the domain, shipping, affects something that is totally unrelated to shipping, the shopping cart, or changes to prices or the structure of prices affects the current shopping carts. In one word, we have highly coupling across components in the system. So all those arrows are a source of coupling. And the worst one is the one in red, because it's violating autonomy more than the others. Because basically we have one part of the domain trying to issue command to another part of the domain it has nothing to do with. And it doesn't really matter if this coupling is through HTTP requests or a shared database or messages on a queue where we're using them to share data. It's coupling no matter what. So the technology we are using to create this coupling doesn't change the fact that it's coupling. So the reality is that the shopping cart doesn't exist. It's a business concept, and it's a user mental model concept. But if we want to model a system that deals with the shopping cart, we don't necessarily need a shopping cart in the system. So can we decompose the shopping cart, analyzing its behaviors, and trying to understand how can we assign responsibilities to owners? So sales has its own view of the shopping cart. What sales deals with are prices. And as we said, the current price and the last price, for example, or the price history of an item in the shopping cart. So can we move that data to sales and say, hey, sales, take care of the data you care about? And then can we move availability to warehouse and say, okay, quantity and inventory can go to warehouse? Because that's where things change over time and constantly needs to be updated. Can we do the same for shipping, for example? Why not? So we're moving estimated delivery to shipping and say, you deal with that, take care of that. And finally, we can say, well, marketing tends to be very stable. So the only good reason to change the name of and the description of something are typos. So we don't really need to denormalize anything. Because products will live forever in a system like this. We're just discontinuing a product. We're never deleting a product. So there is no risk of deleting something that is virtually connected to an order. It will be discontinued, so it won't be available on a product page. But if you go to your order page, you'll still see the name and the description of something you bought 10 years ago. So that's not a problem at all. So at this point, do we need a shopping cart at all? And the answer is probably no. So one thing that we can do at this point is saying, is there one of these items or services or microservices, if you will, I don't like the word microservices, but, or aggregates that can be responsible for the business concept of the shopping cart? And probably, in this case, can be sales. So we can say, hey, sales, the cart identifier is your business. Because that was the only thing that were left here. It's the cart ID. So we're moving that thing to sales because we can say, we can safely and easily identify for every business scenario, there will be an actor or a component in the system that is logically responsible for that kind of scenario. And in the case of a shopping cart, is sales, my very simple sample. What did we do? We didn't really change anything in the system because we changed no data. We changed no behavior. We removed the concept. Yes, that was a change in the end. But the real thing that we just did is that we followed the coupling. So coupling, in the end, is something that we cannot really get rid of entirely. There will be always some sort of coupling in the system. So we need to accept that and say, okay, can we work around the thing and say, basically say, things that change together should stay together, or maybe must stay together. So whenever the price change, all the prices in the shopping cart must be changed in some way. So they should stay together. But if shipping delivery estimates change, it has no relationship with prices at all. In which case, they don't have to stay together. Hence the reason to not leave them in the same shopping cart concept. So we basically accepted some sort of form of coupling and said, okay, we need to have that, we need to deal with that. Let's design our system around coupling. Unfortunately, now the information structure doesn't fit the user anymore. Because now we have information or data scattered around the system, and but we need to display a shopping cart to the user. Because we cannot expect users to navigate multiple pages, one saying, hey, based on this globally unique identifier, your stuff that you don't know yet what it is costs $10. Then go to the next page, remember the globally unique identifier, and you'll discover the name of the thing. That doesn't really work in the end. So we need to be able to display this business concept to the user as an atomic thing, as a monolith, in lack of a better word. In such a scenario, can read models be a solution? So, given our 5 services in the system, or 4 and whatever we want to add to the shopping cart, can we say, what if we push data in some way from these services to a storage? Let's call it the view models storage, or the read models storage, and then have clients talk to that storage to load the shopping cart. Why not? So we're basically building a kind of denormalized view that we need when we need to display the shopping cart. So in this storage, we can have that kind of business concept we started from, that was the shopping cart structure. If we try to do that in a system where data are owned by services, that's not a read model, but that's a cache. It's more ugly now, no? So, why it's a cache? Because every single time we're pushing data outside the boundaries of a service, that service is losing ownership of data. So now data are in a kind of land of nowhere, where can sales change the structure of how prices are defined? No. Well, they can, but the only option they have is, hey, cache, can you please wipe everything related to shopping carts? And then expect everyone to be touched every single time a user needs to display the shopping cart in order to reveal the cache. Because that kind of monolithic read model outside the boundaries of a service is not owned anymore by anyone. So it's very hard to implement, for example, different caching policies. Because sales might want to cache a price for 5 minutes, where marketing says, well, I can cache stuff for years, I don't care. So again, we're losing autonomy by building this kind of outside of services cache. Why? Because whenever something changes for a service, let's say cache needs to be invalidated, that service is basically pushing responsibility on other services to do something, that is to rebuild their part of the cache. And that's again, lost autonomy. So, and by the way, the problem is that we cannot cache everything. On that product page, they tell me, we cannot ship this product from Amazon.com to the place where you live in Italy. I intentionally picked Amazon.com as the source for the screenshot. So that information cannot be cached. It must, unless they are caching every single possible combination of every single product and every single user and every single shipping address. That doesn't really work. So what they're doing is that they're probably evaluating on the fly where the logged in user will ship that product from where, and say, we cannot do that. And they cannot really cache that information into a kind of read model outside services. So let's step back for a second and say, what do we have? If we carefully look at what we have now, is that we have shared identifiers. So all the services are sharing primary keys that are exactly the same. So the item ID in the shipping concept of the shopping cart is basically the same item ID in the sales concept of shopping cart that is the same in the warehouse concept of shopping cart. So can we benefit of that in some way? And there is, well, view model composition comes along. And we can say, well, let's imagine a client, whatever a client is in this context. In my sample is a browser, but that doesn't really matter. So a client that is requesting something like a product. So it's product/1, a kind of a key. The browser needs to deal with these 5 services. And as we said, the identifier is shared across services. So why cannot the client go directly to services and compose that view model on the fly? So we already have information in these services. So the client can issue 5 different web requests to 5 different destinations, retrieve data, and then have some logic to compose back information into what the client expects to be the read model or the view model, whatever we want to call it. Said like this is truly inefficient, okay? But let's try to visualize the thing in a different way. So what if we have an incoming request that goes to something that we can call some sort of composition gateway? And if that brings in your mind the concept of a reverse proxy, that's perfectly fine, right? So some sort of composition gateway, where the first thing the composition gateway does is something we can call request matching. What's request matching? Request matching is the act of going to services, and we'll deal with what that means in a second, and say, is there any one of you interested in that specific HTTP request, that is the URL? And maybe, in this case, 4 of them will say yes. We are interested in that. What the composition gateway does now is basically go to them once again and say, now do your job, compose data based on this HTTP request. They go back to their own backends, retrieve data they need, pull them into the composition gateway, and finally compose the view model. And the view model is then returned to the client. So let me try to describe that in a very trivial way. Imagine 2 for eaches. So there's an incoming HTTP request, there's a for each that goes over a set of classes, calling a method that says, are you interested in this? Yes, 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 no. The first 3 are interested, yes. Again, a for each over the first 3 saying, fill this, where this can be a JSON that starts as an empty JSON. That is a very nice way to define a dictionary. And everyone can put data into that kind of dictionary that is then returned to the client. So let's try to implement that in code looking at the price. Just that. Sounds like a very simple information on a product. This is a kind of pseudo C# code. So we have a class called product details get handler for sales that implements an interface. The first thing that interface demands from the implementation is a matches method. So what's coming in are route data. I'm using MVC core in this case. So it's the routing information from the current request and the verb. Is it a post, get, patch, put, whatever. And what the method is doing is simply doing, well, is it a get? Yes, I'm interested in that. And it must be products containing an ID. So the template of that specific HTTP request should be /product/ something that can be converted into an ID, whatever that means for that specific system. If this is yes, so it's true, then the composition gateway will invoke for that specific class the handle method, where the handle method is as simple as retrieve from the routing information the ID, so the current key, 1, in the original sample we started from, go back to our backend, in this case using HTTP again, but that can be whatever we want, we'll deal with that in a second, retrieving data through the HTTP response, and finally compose that into the view model. As you can see in C#, in this case, the view model is a dynamic thing. The intent here is to keep the sample as simple as possible without introducing too much infrastructure into the sample. But for people not used to C#, dynamic is not that different from a JSON object for JavaScript. So it's something that can be whatever you want, basically. So basically, we're basically telling the compiler at runtime, so the dynamic language runtime, please invent a product price property for me and put this value into the product price. That's it. So basically, if this was the only one actor acting in that composition logic, the end result is a class instance called VM, where there's a property, product price, whose value is this one. As you can imagine, there will be someone for marketing saying, I'm interested in /product/1, retrieving the name and the description of the product, and doing the same thing, product name and product description. So basically, at the end of the composition process, there will be a dynamic VM containing all the properties required to satisfy the shopping cart or the product page details. It's very important to say that now these components are owned by services. So the sales handler or the marketing handler or the shipping handler is logically owned by the service. That means that they are not constrained to HTTP at all. There's nothing wrong from the logical perspective that sales talks directly to its own database or to a cache, but that cache will be owned by sales, meaning that the invalidation policy will be 2 minutes. And marketing can say, okay, I have my own cache where the invalidation policy is 30 days. I'm warehouse, I have no cache, I do no request, I just use a random number for availability. That's perfectly legit. The other interesting thing is that now every single component has another interesting opportunity. That is, what happens in case of failure? So what happens is if my backend is not available at the time the user is requesting that page. Now, every single component can say, well, in this specific use case, I am mandatory. That means if my backend is not available or my cache is not available, so the price cannot be retrieved, 404 or 500 as a response must be the result. So the component should throw an exception and fail the entire request. Let's imagine customer reviews. Does it really matter if there are 26 or 30 or 14, or if it is a 5 stars or 4.5? If that specific marketing component fails in doing something, we can invent a number. Or just make so that the information disappears from the page by returning null. And the logic on the page can say, okay, I got no response for this specific case, let's just hide the div from the page. So now, components have this ability to react to failures that was unavailable before, because the cache was monolithic and no one owned it, and we had no idea what to do when something was going wrong. Obviously, what about rights? Now, let's imagine you want to add something to the shopping cart. Now, that's a little bit more problematic now, because we have an incoming HTTP post that should be split into multiple requests or something like that. So in this case, we're going to use the sample of quantity. So all these services needs the quantity for something. Sales needs the quantity to calculate probably discounts. Warehouse needs shipping needs the quantity to evaluate delivery estimates, because maybe they realize, okay, to ship this amount of stuff, we need a larger truck and we cannot ship it tomorrow, it will be shipped next week. Or warehouse to estimate, do we need to refill the house because we will go out of stock after this order, or things like that. So view model decomposition works very similarly to composition. So we have the browser that does a post that says, well, I'd like to add this item ID with this quantity. These are the information on the page. If you picture in your mind the Amazon web page, you have a drop-down selecting the quantity and then the add to cart. So what happens is that that information travels into the system, and using a similar technique, it should go to these free services. Now, can we use HTTP here? No. That's problematic, because things usually go horribly wrong. So if we use HTTP there, what might happen is the following. So we have an incoming post request that goes to the composition gateway. Oops, sorry. We have an incoming request that goes to the composition gateway, and if we have HTTP there, what happens if one of them fails? There are no transactions in HTTP. So the problem is that if we issue free HTTP posts, or we talk to SQL and Mongo fails, we cannot rebel SQL. If one of the SQL fails, we can rebel one, but we cannot rebel Mongo. So it's a cat eating his own tail, Italians would say. So it's a kind of a never-ending story we cannot really fix. So we need some way to guarantee that eventually the system will be consistent, no matter what. So one thing that we can do is basically receive an incoming HTTP request, have a component that transparently transforms that request into a message that is sent on a queue to itself. So I'm sending a message to myself containing the payload of the incoming HTTP request. It's serializable by default because it was on HTTP. So I put that on the queue and send it to myself. Then I receive it, and when I receive it, it's received by using the same logic by all the components interested in this specific request. And what they do is that they send out messages to their backends. Why messages everywhere? Because on queues, we can guarantee consistency eventually. That means that if something goes badly somewhere in this process, one of these messages will fail, whenever this handler will fail, the incoming message is retried. So depending on the queuing technology we're using, let's say the best one in this regard would be MSMQ. There will be a distributed transaction by this incoming message and these outgoing messages. So the third one fails, no one will go out, and this one is retried. Using things like, on the other side of the spectrum, RabbitMQ, where there are no transactions at all, we can use things like the outbox pattern to guarantee that there will be idempotency across message handling, so that these services will receive maybe multiple copies of the same message, but the outbox pattern guarantees that they will process them only once based on the message ID. So it's like they are doing a kind of a distinct of the message ID, and they will just process one of them, discarding all the others. So basically, the queues allows us to survive to failures, and it will be eventually consistent. That's the reason why when you go to Amazon and say, add to cart, you don't transition to the cart page immediately. There's that page in the middle that says, thank you, we added to the cart. People that add this to the cart also add these other products. You lose enough time that guarantees that the system behind the scenes is, okay, I'm done. And if you transition at that point to the cart page, your cart is consistent, visually consistent. Okay? So what do we have now? A thing that we can finally call vertical slices. So we have services that fully owns behavior, data, and the part related to building the view model for the UI. So every service now is fully responsible of a vertical slice. That is everything they need to do, whatever they need to do from the business perspective. So in order to guarantee that these slices are cut correctly, we basically want to be in a very nice and maybe hard to achieve position. That is, whenever a new business requirement comes in, it affects one single slice only. That means that these services are really fully autonomous. They can change however they want without telling anything to anyone. And that's not a problem at all. Unfortunately, however, services need to communicate in some way between each other. So the business comes along again and say, you know what? For, I don't know why, these are the requirements I came up with. If something stays in the cart for more than a week, I want to annoy the user, sending them an email. Because maybe they remember that there's something in the cart and they buy. And if something stays in the cart for a month, just wipe that cart. Because, I don't know, disk space costs too much to us. Whatever, that doesn't really matter. So what could be in this case a services communication channel? Do we need consistency in this case? Not at all. So it's something that happens in the background to some extent. So whenever something is added to the cart, who owns that logical behavior? We said that it's sales. So the add cart to item business operation happens in sales conceptually. So whenever that happens in sales, what sales can do is do something like, let me set a 1 week timeout. What's a 1 week timeout? It's a message in the future. Sales is sending itself a message that will reappear in the sales input queue in 1 week. And will set a 1 month timeout at the same time. That is, okay, send me a message in a month. Probably that message just contains the cart ID, because what sales needs to do is correlate it back to what was the cart I need to do something about in a week. Fine. So when that message comes in, so the 1 week, for example, timeout, what sales can do is publish an event that is, hey, cart got stale. That event is interesting for marketing only. It goes over a bus to marketing, and marketing will notify user through an email, sending them an email saying, hey, your cart just got stale. Do you want to buy what you put in? And then a month after, the cart expires, basically. So the cart expired event is published on the queue. That's interesting for two services, shipping and warehouse, because they need to wipe data. Those are the services, other than sales, containing data related to carts. So what they do is that they receive this message and they just wipe cart, their view of the carts. But what's the interesting thing in this case? If you think about it, what these messages contain are just IDs. So if data are correctly split across services into their own service boundaries that are very hard boundaries, what we need to share with messages are just IDs, nothing else. So what's enough for services to change their state is the semantic meaning of the event, cart expired. That's basically is a never-changing thing. The only way to change is that the business says, well, we don't care anymore about this business scenario. That's it. So the event won't be ever published anymore. And then the cart ID. That's it. That is a primary key that should never change, hopefully. Because if we have primary keys changing, that we have a much bigger problem. So that means that the final big picture is something like we have services containing behaviors and data, and they talk to each other using a bus, and they display data on a UI using the view model composition technique. So we have finally vertical slices, and we have these two very thin layers at the back and in the front that are basically communication layer. They are both basically communication layer. Obviously, in 40 minutes, and we just have 1 minute, it's very hard to demo thing. There's a demo available at that link. Slides are available at the second link. And here you have Udit Han, that is my boss, by the way, talking about service boundaries. So to summarize, takeaways. The most important thing in designing complex business software systems, probably the only important thing, are boundaries. If you get boundaries wrong, you're in trouble. one sign that I usually use as a kind of a smell for wrong boundaries is technology. By the way, I hate technology. So whenever I feel the need of introducing new technology in order to solve a problem, I always question, why are we doing this? Do we really need that piece of technology? Or is it kind of a palliative to hide a problem under the carpet because we're using this cool new thing? So, and a cache is a clear problem, especially if it becomes a distributed cache. We probably experience that sometime. The other thing is that the user mental model is a bit tricky. So users, even domain experts, they usually talk about information as they are displayed on a screen. So it's very easy for them to talk about, oh, there's a shopping cart, or there's a product. And we as engineers immediately transform that into public class product. Oh, it has a name, public string name, and public decimal price. And then we're basically screwed because we already transformed that from the monolithic view of their mental model, that's perfectly fine, into the bad monolith of the system. So we should be very, very careful in translating the user mental model as is. And the other important stuff is do not name things prematurely. Because names stick, and it's very easy to then say, well, we have the concept of a product. It's clear that the price belongs to the product because we named that product. Use planets, use colors, use letters of an alphabet, whatever. Just don't give a business name to a thing until it's clearly defined what it is. And then you'll end up discovering that there are things that cannot be named in business, using the business lingo, because they are processes. What we thought were data are instead processes. And in fact, if we dive deeper with the business, they will call them policies. So it's the discount policy, it's the shipping policy, and things like that. But at the very beginning, they'll start talking about data, and it's on us to try to steer them into what's the behavior? I don't care about data. Describe me the behavior. That's the important bit. So behaviors define how to aggregate data. And the most important thing is the first one. Group data that change together should stay together. That's it. So the anti-requirements technique is something as stupid as, will there be a use case when the first letter of the last name is S, like in my case, that we're going at 10% discount to people? And that's obviously a no. So there's no point in keeping together the first name, the last name of the user, and the price. But probably at that question, they will reply, well, but there's a case in which if it's their birthday, we want to give them a discount. That means that the user birthday goes to sales in the decomposition. And then it's very hard to define that thing a price, because that thing will be a combination between a price, the current discount marketing policy, and the user birthday. It's a discount policy, it's not a price. So it's the process of calculating the outcome that is the price. That's the important bit. And finally, use composition techniques to present data to users. So that's the key of eliminating that cache thing that is, again, a kind of a monolith that sits like the elephant in the room. Okay? The last bit is there is no such thing as orchestration. So you never need orchestration. If it is an event-driven system, events should suffice. There's never the need of an overarching orchestrator and say, do this for me, do that for me, here is the state. That's usually the result of the user mental model, because they want to see the my products page or my order status page. That is the summary of the view model composition technique. It doesn't need to be an orchestrator to achieve that. So these are the last important bit. As said at the beginning, my name is Mauro Servienti. I made it in 45 minutes, and thank you very much.